All right, so here we are asked specifically to use the second derivative test to find the extrema. And if this appears on your test, I will be very clear about you must use the second derivative test to find the relative extrema. So yes, we have the first derivative test, but if I put this on your test, then I'll be really clear and say you must use the second derivative test. Okay, so how are we going to do this? The first thing that we do anytime you're finding extrema, you are going to find the critical numbers. That is non-negotiable. You have to find the critical numbers. The second thing is you can either use the first derivative test or you can use the second derivative test. And here we are opting for that second derivative test. And what the second derivative test says is that you're going to plug critical numbers into the second derivative. All right, so we're not doing the first derivative test, we're going through the second derivative test, but anytime you're asked for extrema, you must find critical numbers first. Now, there is a little bit of a nuance here. The second derivative test does not work when the derivative does not exist. So you will see on the questions that are given, they don't have a condition where the derivative does not exist. Everything is going to be about f prime equal to 0, and we're never going to check that does not exist component because the does not exist actually is not included as part of the second derivative. So we're just looking at first derivative equal to 0. All right, so if I set my first derivative equal to 0, the first term will go to a negative 6v. Second term is a standalone constant, so that goes to 0. And then the last term is a linear term, so that goes to 4. We set that equal to 0 and then solve. So subtract 4, divide by negative 6. And that gives us v is equal to positive 2 over 3. Now, that is the first derivative equal to 0. That is our critical number. So what we could do is we could draw our number line with the first derivative and test. Instead, we're using the second derivative. So here is where, for the second derivative test, there's no number line. And instead, what we do is we plug in the critical number into the second derivative. So I do need to take my second derivative or find my second derivative. So negative 6v is a linear term, so that will just go to negative 6. And then the plus 4 is a constant, so it goes to 0. Now, this is a really cool question because if you look at plugging in the critical number of 2/3, there is no x there to plug in, right? You just have negative 6. So there's nothing to plug in, you're just getting negative 6. So either way, what you're going to see is that your second derivative is negative. And when your second derivative is negative, that tells us it's concave down. Now, if it's concave down, what should we have at that horizontal tangent? We would have a relative max at the critical number. Specifically, the critical number here of 2/3. So this is where they do want the max point. So once we know we have the max at 2/3, we then take our little t-chart, plug 2/3 into the original function. So the negative 3v squared minus 5 plus 4v. And when you do that computation, it will give you negative 11/3. So that tells us that we have a relative max at 2/3, comma, negative 11/3. Now, in terms of the minimum point that we have, there is no local or relative minimum. And I do want to just point out, when they're referring to local, that is the same thing as relative. So don't get thrown by that. If it says local, it is the same thing as a relative.